So welcome to our next demo. This time I'm going to show you how to configure your Google computing platform to transfer data from the computer to the BigQuery table and back. When you look at the simplified version of our pipeline, we can see that in the first stage we have raw data which needs to be extracted and analyzed, and later then prepared for modeling, which will result as a next stage. We'll have model training, model evaluation, etc. Both raw data and trained model are artifacts, and these actions, the scripts, are so-called components. We are now here in this section. Typically, when you work with some data, for example, coming from your company or your customer, in the first step, you are going to have some data prepared by data engineers, and then you will have to know how to extract this data to your computer or to some computer which is hosted in a cloud in order to analyze that. So I'm gonna show you two different procedures. First one, which is quite a bit simpler than the second one, we are going to work on our local computer, local notebook, for example, and with Visual Studio Code, we'll use the Python script to push data to Google BigQuery. We'll create some artificial dataset and push the data to BigQuery. It corresponds to the final stage of your pipeline where the sample data are, for example, the results of the inference of your model, and you would like to push it back to your customer to be later on processed, for example, via CRM systems, whatever. Next, since it's a bit more sophisticated, I'm going to show you how to extract data from Google BigQuery to your computer in order to prepare for modeling, create the model, and do all other stuff. So that corresponds to our first step in a pipeline. And since it's quite easy after this demonstration, I would like you to make a kind of the experiment at home with something like that. So you can work on your own computer and then use Microsoft Visual Studio Code or your favorite IDE to connect to some hosted server, like hosted on GCP, where you run the Python script and push the data from this machine to Google BigQuery. Okay, so the only difference would be that your processes will run not locally, but on the hosted GCP. And you'll just simply use your computer with Microsoft Visual Studio Code as a terminal to something which is happening in the cloud. Okay, ready? So let's continue. So let's do the job. The first thing I'm going to show you is how to transfer the data from the data frame you have created in your Python script to Google BigQuery table. We are going to work in the following steps. As a first thing, we are going to create a dedicated Conda environment, as always. Next, authorize your computer to be able to use the script, Python scripts, to transfer the data to the BigQuery table in your account. That's an extra step we need to do. Next, we will create a simple script on our local machine that will transfer this data. Okay, so let's start with a new environment. I have already my Visual Studio Code opened in the empty folder demo data transfer. I open a terminal within Microsoft Visual Studio Code. By the way, there is a handy shortcut for this, Control tilde, so you can do it with the shortcut. And I will create a new Conda environment with this command. That's just to refresh. So I create a new environment named ACI with Python 3.12. Let's do it. And then I activate this environment. And in this environment, we need the following libraries installed. So what do we have here? We have pandas, pandas-gbq. So this is something which helps us to transfer the pandas DataFrame to Google BigQuery table, a Google Cloud BigQuery client just to connect, and PyArrow as something which will help us to work later on. So let's make the necessary installs. And we are done. So the next step is to authorize your computer. For that, I suggest you to follow the tutorials, set up application default credentials, tutorials by Google Cloud. Once again, I use GCP only for illustrative purposes. If you would like to work with Azure, which I also recommend you, or Amazon Web Services, it's a very good exercise to do what I'm doing now with another cloud provider. They will have obviously technically a bit different ways of authorizing your computer, security aspects, etc. But the general idea stays the same. So for GCP, this is a tutorial, set up application default credentials, and here, and I have already done this on my computer, this is the most important step. Without that, you'll get errors when running your Python script that you are not authorized to push the data to Google BigQuery. So you need to have this installed. We have already done it previously. gcloud command line interface, and this command is key for you. Okay, so here we create your credential file. So I assume that you have it already done. So the next step will be to prepare a BigQuery table in our project. So let's come to our terminal, to our GCP console, and here we have BigQuery Studio, and within our project I can create a new dataset, and I need to specify the region. I already told you that's very, very important for cost, speed, GDPR, etc. So I need this dataset precisely in the place where I'm gonna use my virtual machines. For this purpose, I'm not gonna use my virtual machine to communicate with BigQuery, but later on we'll use it. So I just simply keep this as a good practice. I create a dataset. I need to make a name, so I create this dataset with my first dataset as a name. So I create a dataset. Okay, so it's already there. In this dataset, I may have multiple tables. I can create those tables now, or I can create this table from my script, which I'm gonna use in this demo. So let's continue. And now, in my Microsoft Visual Studio Code, I'm gonna create a new file. I will save it as 1.py. Okay. And I will paste here a simple script, explain you how it works. Before we run the script, I strongly recommend you to, we need to do this by the way, look here at the bottom right. At the moment, Visual Studio Code uses a default Conda environment or code interpreter. In order to proceed, I need to activate our new environment, which is here. Okay, and now all our functions will work correctly. So let's walk through. First, you have some imports. So let's make those imports. I'm gonna run this in the interactive Jupyter window, interactive terminal. By the way, this is the way how I work with interactive code. So instead of using Jupyter Notebook, I'm just simply using interactive window in Microsoft Visual Studio Code, which gives me the same feeling and the same experience like Jupyter Notebook, but directly within the Python. Okay, so I have all the options like running different checking for values of different objects, data frames, etc., or variables. Okay, so this is the. So I have simple imports. Next, we initiate the client. Now it's initiated. Next, as you can see, I have dataset name and table name variables, which specify the dataset name and the new table name I'm gonna create. And then, let's have a look here. I specify the table ID as a string, which contains client.project. By the way, project here is directly taken from the default project within the Google Cloud command line interface. So I wonder if you remember when we initialized the Google client on our computer, when we make the first login, it asked us for the default project. If you would like to create a table or a new machine, connect to another machine, another project, you should specify the project name here in this client class. So that's why I have this client project variable here. So it is taken directly from this object. But then we have a dataset name. So as you can see, this is the project ID. This is the dataset name, my first dataset, and this is the table name. So this is the table ID as a script, and we can check it now as this variable. It looks like that. As you can see, it has taken ASI2024 minus 415408, which is my project created for this course, yes, and my first dataset, my Python. Very good. So then I have a very simple data frame, extremely easy, which looks like this one. Yeah, as you can see, there are 2 columns, 2 rows, numbers, letters. Then I specify the schema for my BigQuery, which is, by the way, optional. It can be auto-detected by Google, but let's do it. Then, most important thing, I create a job config. So let's have a look how it looks like. It is here. And now the most important line. We will load the table from our data frame to the table using those configurations in the job config. Okay, and now we can test the job result, and it's here. So now it's time to check how it looks like in our BigQuery. If we refresh the project now, and go to my first data set, you have my table from Python, and we can see details as a schema, when it was created, etc. But for us, the most important is preview. As we can see, we have our data set from our local Python script pushed to the Google Cloud BigQuery, which completes our job. Okay, so in the next part of this tutorial, I'm going to show you how to read the data from the large BigQuery table to the local machine. See you in a second. Okay, so now let's continue with the second step. Now we are going to transfer the data from the BigQuery table to our local machine. Seems easy, and it's not that difficult, but I will use this situation to show you how in practice you can transfer big data from external storage to a BigQuery table. And for that, I'm gonna use this very interesting dataset. You can find the hyperlink in my course materials. This is the Iowa liquor retail sales dataset. Interesting because due to some legal regulations in the Iowa states, all the shops which sell alcohol are required to report detailed sales of the alcohol. So we have this dataset publicly available in Google. If I click this link, view dataset, as you can see, it appears in my console in Google Data Studio. And if I click this, there are plenty of different datasets here. And if I click Iowa liquor sales dataset and sales table here, I can see many different columns. I can see in details that it is just being updated. It's quite fresh. And total logical bytes 7.75 gigabytes, physical bytes 643 megabytes. So it's quite large data set. I can see also, I can check the preview of the table. As you can see, you have plenty of different rows like invoice and item number, date, store number, store name, address, location, county, category, and as you can see, item number, and this is interesting item description, Jägermeister liquor pack 12 bottles. Yes, so you have all the data about alcohol sales, by the way, which might be interesting for your project. But now the question is, how can we transfer this public data set to our BigQuery table? It may be easy. You can see that there is an export button here, but in practice it becomes really tricky because you transfer more than 1 gigabyte of data. So how to cope with that? I will show you how to work it out step by step. So the steps will be the following. Firstly, I will create a Google Cloud storage bucket, which is just a place to store a data, unstructured data. You may think about this as a kind of the file system or data lake, whatever you find it. And then I will use this export to GCS, Google Cloud Storage. So then we will transfer the data in a specific format to this, to my bucket on my account. And next, I will import the data from this bucket to my BigQuery table. Okay, so that's gonna be those steps. Ready? So let's continue. So the first step now is to create the bucket. As you can see, I have quite a fresh project. I have no buckets. So I will create the bucket. I will name it, for example, ASI2024. Let's check whether it's accessible. Okay. Nope. Oh, that was a typo, but let's check. Let's correct this typo. I see minus 2024. So let's continue. Where do you want to store your data? I will store it in a very specific region. I told you that this is just my sanity check, and the good practice to keep always the same region, to collaborate with some other machines. So I keep my data and servers in Europe, specifically in Europe West 4. Next, choose a storage class for you. There are plenty of different options. It depends on the use case. There are different courses on that, specific courses only on this. The very similar use cases are described in Amazon Web Services courses or Microsoft Azure. Once again, I'm using Google Cloud just for illustrative purposes. I'm gonna use standard one and continue with the access. I enforce public access prevention this backend, so I don't want public to access the data. And yeah, I create the bucket. So now I have my bucket where I can store the data from this liquor dataset. So now the next step. I go to my BigQuery table console. I have this dataset already active, as you can see, and I have now export button and export to GCS. And before I continue, I need to choose GCS location, but I will start with this. As you can see, you have many different options. And you can play with that, and you will see that CSV will generate errors. You transfer more than 1 gigabytes of data. So if you transfer this data set and then try to read this to BigQuery table, it will generate error. It's too much. Parquet, if you give it a try, it's much better than CSV because it has much higher compression and it's just still binary file, but it will still generate some errors because it does not allow you to transfer data between geographical errors. The only thing which worked out for me was Avro file, which is used by Google. It's very, very handy. So I choose this one. And now if I choose GCS location, I will choose this bucket, and here in the file name, I need to type sales minus and star because it will create a plenty of different small dataset. It's gonna to transfer this data in form of small packages, and all the files will start with sales minus, and then we'll have some extra numbers added for the files themselves. So then if I click select, I choose no compression here. So let's try to save it now. Save export has been initiated. Okay, and now we can check whether it worked. Let's have a look at our bucket. Yep, I have a lot of different files in my Docker. As you can see, they are in the form of multiple files, each of approximately 50 megabytes size. So it looks like I have it there. So the next step will be to transfer this data to my BigQuery table. But in order to do this, I need to create such a BigQuery table. So now let's come back to my ASI project. It's here. I have already created a dataset Iowa. Okay. So I need to create a new dataset. Then I will create a new table in this dataset. I will name this as a source. I will choose Google Cloud Storage. Okay. Then, so I will choose the file. So here I'm gonna have multiple files. So once again, choose sales minus star. So I select all those files. Destination project, dataset Iowa, and table, I will name it sales. Okay, so as you can see, I specify destination on the project. And dataset is Iowa. Yep. So now let's create the table. Okay, so now I have it done. I can go to this table and it looks like we have it. Can you see? Number of rows, huge number of rows. Let's preview the table. Yes, we have the data. So we are done. But now, having that, it's still a large data set. So let's make a simple query with that. So imagine that now I would like to print all the columns in this data set. So I have this query. Okay. I can, for example, ask, I have it prepared, just a simple query for me. Look, it will select dataset is Iowa e-commerce, that's Iowa. Yeah. I can run the query. So I can see, as you can see, I can make a simple query which shows me all the columns. That will be useful in case we would like to select some columns from my Python script. And you may also ask for another query, like to see different unique stores in this dataset. I need to correct the dataset because in my case it is Iowa. So now once again, as you can see, select count distinct store number as unique store count from this is the project, this is the dataset, this is the table. So let's check it out. Yep, I have 3038 different stores. So as you can see, I can run different queries over this dataset. So if I can do it here, I can also do it in my Python script, which I'm gonna do later. Okay, and the final touch. As you can see, this dataset is huge. We have approximately more than 3,000 stores. So this data is too large to be downloaded to our computer, or we just simply do not need this. In machine learning, in many cases, we work with samples. So let's make a simple query which will sample the dataset for only 10 stores. I have this SQL query prepared. Oops. I need to copy paste this. Okay, so what we can hear? We have. I need to correct a small typo here. Yes. So let's run this. Okay, so it's already running. So this is the result, and I can save the result to BigQuery table. And within this dataset, Iowa, I will create the sample 10 stores tables. As you can see, this is also very handy because I can query a large table and I can save the results to a sample table. And now I have in my dataset, Iowa dataset, a much smaller table which is ready to be downloaded. And that's gonna be the next step in our procedure. Okay, so now we are ready to continue with our final step. We have our table already there. Its name is sample 10 stores. And as you can see, I have a simple script here in my Python script on a local machine. As previously, I initiate the client, then, and this is very interesting, I have a query as the large string where I can choose different columns from my table, yes, in a given project, as you can see. So from requires me to specify the project ID, the dataset name, and the table name. And finally, as you can see, I read this with PD, but here I have a method read underscore gbq. So this is taken from pandas gbq library, which I have installed previously. So now let's try. Okay, and now it looks like, yep, we have a data set on our machine. So that concludes our tutorial on data transfer between your computer and BigQuery. What we did it twofold. Firstly, we uploaded some data from our local machine, from our Python script to the BigQuery. Secondly, we downloaded the data from the BigQuery to our local machine. Just in the middle of our journey, we had a chance to cope with big data. stored in some external large dataset using Google Storage as the interface and Avro to transfer the data, so you had a sneak peek of big data. So I think that it prepares you to work with your customer. Firstly, to download the data, next to process this data, and finally to bring the user back with predictions from your local machine. At home, I strongly recommend you to make an experiment with the same scripts but running on the hosted machine. Specifically, for example, virtual machine you run on Google Cloud or Azure or AWS. You will probably, the only difference will be with authorization, so you have to play it by your own. And good luck. Thank you.